In this unit, we're going to take a look at work. Now, work in the everyday definition does not mean what work means in the science definition. Work is done when you apply a force that acts through a distance and it transfers energy. So there's two definitions of work. The first definition that I like the most is the transfer of energy. When work is done on an object, energy is transferred from the thing doing work to the object on which the work is done. So it's the transfer of energy. But it is also a force acting over a distance, or a force acting through a distance. Now, in order for a force to do work, the force and the motion need to be in the same or opposite directions. So force acting through a distance. And in fact, there's a mathematical definition of work as well, and that is force times delta x. Or if you'd like, you can say that's force times distance. But remember, it's not really distance, it's displacement, which means it can be negative. So let's take a look at three scenarios. If I have a cart that is being, let's see, pulled along the ground this direction, there's the force, and it's moving this direction, motion, then this force is doing work. So this is work. Now, if I have somebody who is pulling at that cart, but they're pulling up at an angle, sort of like this, that's the force, and the motion is this direction. This is some work because some of this force is actually in the same direction of the motion. Some of that force is this way, some of that force is up. This part of the force is doing no work because it's not actually causing this displacement. If somebody were to have a block and they were just pulling on it, but they couldn't get it to move, no motion, that's not work because there is no displacement. Even though you are putting in lots of effort to try to get this thing to move, if it's not moving, then you're not doing work on that object. And then that actually brings up an interesting case. What happens if I have a guy walking down the street and he's got his backpack strapped to his back and he's just walking this way? He is holding that backpack up, so he's exerting a force up on the backpack. His motion is forward though. This force is not causing this backpack to displace. It is not moving that backpack up. So this is not work. Okay, so in order for the work and in order for the force to actually do work, they need to be in the same direction, or they could be in opposite directions, but you can't have them perpendicular to each other. A force that's perpendicular to a motion does not do work on that object. Now, let's take a look at calculating a couple examples of work, and then we're going to get into the transfer of energy, or how we define work as the transfer of energy. So first, the equation for work, force times distance. Let's think about lifting a box that weighs 10 newtons, and if we lift it 2 meters, then what we do is 10 times 2, because we have to apply a force of 10 newtons in order to balance gravity, which is down 10 newtons. So we're lifting at a constant speed. 10 times 2 is 20 joules of work. So the SI unit of work is joules because it is transferring energy. It is a kilogram meter squared per second squared, which is a joule. So 20 joules of work to lift that thing 2 meters. Now, let's say we have a shopping cart, and it takes 5 newtons of force to push it that direction, and you do 20 joules of work pushing it. How far did you go? Well, 20 equals 5 times d, and that's divide by 5, 4 meters. So you can calculate work any way you'd like, force times distance. But let's say that you push the brakes, they exert 200 newtons back on a 1,000 kilogram car. How much work? Well, technically, this 200 newtons is negative. It's right, we have a car here. The brakes are going to push this way even though it's moving that way. So my 200 newtons is against the motion, and so how much work if they last for 10 meters, say. Well, this is irrelevant. We don't need that. Force times distance. So 200 newtons over 10 meters, 200 times 10 is 2,000 joules, but it's actually negative 2,000 joules. And the reason it's negative 2,000 joules is because the force was to the left even though the motion was to the right. And since those are opposite of each other, the work is negative. Now, what in the world does it mean to have negative work? Well, it actually does make sense if we think about it in terms of energy. Okay? When an object has energy, it has the ability to do work or cause change. But when you just stopped that car, you gave it less energy. You gave it less kinetic energy, which means it's got less ability to do work, it's got less ability to cause change, but energy can't be created or destroyed. We know the law of conservation of energy. So what happened to it? Well, when you did negative work on it, or the brakes did negative work, it actually converted that energy into heat or thermal energy, but it took it away from the car. The car no longer has it. So energy and work, what we say is positive work transfers energy to an object. Negative work takes energy away. So there's two ways to think about work: force times distance, or the gain or loss of energy. If the force and motion are in opposite directions, then you have negative work. If the force and motion are in the same direction, you have positive work. But it makes more sense to me to think about it in terms of energy. Positive work causes the object's energy to increase, where negative work is going to take the energy away from the object. So but that first problem, when you did 20 joules of work to lift an object 2 meters up in the air, you actually gave it 20 joules of potential energy. And so that 20 joules of work you did is now stored as potential energy up here. And if it were to fall back down, gravity would do work on it and change that 20 joules of potential energy into 20 joules of kinetic energy. And then it would hit the floor. The floor would do work on it, and the floor would change that energy into 20 joules of sound energy and heat energy, and it would no longer be in the mechanical form, but rather in vibrations in the air, in a little bit warmer air, a little bit warmer book, and a sound wave. Okay. So work transfers energy from one place to another. Positive work gains energy, negative work loses energy.